Welcome to Fast Philosophy. This video is part of our Translating Into Propositional Logic series and explains the grammar and scope of two-place logical operators in well-formed formulas. Now that we understand the tilde's unique scope properties in virtue of it being a one-place logical operator, we can move on to the scope of two-place logical operators and the rules of grammar which dictate their use. The scope of these operators is the smallest well-formed formula to their left and their right. This gives us a grammatical rule. If a formula contains a two-place logical operator, then it is a well-formed formula if and only if there is a well-formed formula either side of that operator. For example, this is a well-formed formula because there is a well-formed formula either side of the caret. This is also well-formed because there's a well-formed formula either side of the horseshoe. This is an ill-formed formula because there is an ill-formed formula to the right of the caret and an ill-formed formula to the left of the vel. This demonstrates the truth which is entailed by our grammatical rule. If a formula contains a two-place logical operator, then it is well-formed if and only if there is no other two-place logical operator immediately to its left or its right. Consider what nonsense we could write if this were not the case. For example, if P equals Socrates likes pineapple and Q equals Socrates likes quince, then this means Socrates likes pineapple and Socrates likes quince. And unless we had our rule of grammar, this would be acceptable. What madness! In well-formed formulas which contain at least one operator, the operator with the largest scope is called the main operator, which is sometimes abbreviated MO. This applies to both one- and two-place logical operators. For example, the main operator in this formula is the triple bar. This is because the scope of the caret is smaller than that of the triple bar. The caret connects two formulas P and Q, whereas the triple bar connects the formula P and Q with the atomic formula R. There are only 6 well-formed formulas. If P and Q stand for any well-formed formula, be that atomic or more complicated, then we can say that the 6 well-formed formulas are P, not P, P and Q, P or Q, if P then Q, and P if and only if Q. Now that we understand the vocabulary and rules of grammar of propositional logic, we must also understand the rules of punctuation before we can begin translating from natural language.